x squared plus 11 equals 24. All right, I'll make sure I've got that one set. Perfect. All right, so now I'm going to subtract 11 from both sides. X squared equals 13. Wow, that's not a perfect square. That doesn't help us much. What we end up doing here is we end up looking at this and saying, I'm going to have to get out a calculator, and I'm going to have to do my own square root. So as I square root this, x is going to equal some ongoing number, a number that doesn't change. In this particular case, plus or minus 3.61, but it goes on forever. What do we call a number that never ends, it never repeats, it's just this ongoing decimal? We call that an irrational number. So now that we're doing square roots and actually working on calculator, we can now entertain the idea of irrational solutions to square roots. You might be lucky and you get them to square root out at 25, 36, 49, 100, something like that. But when you hit the square root, you get a solid answer. You might even get them to work out to fractional ones, like 49 over 36 or 25 over 16. And when you square root those, you get solid fractions. And those are rational and those are fine. But when you square root and you get a decimal that goes on forever and it never ends, that is an irrational answer. We're still going to graph it at negative 3 point, somewhere around here, and a positive 3 point, somewhere over here. We're still going to graph them as if we know exactly where they're at. Just keep in mind they're still irrational. We don't know exactly. Oh, what happens if? Oh, this is a ton of fun. What happens if I get this one? I'm going to throw one more up, and then I'm calling this one done. This is going to be super simple, super easy. Let's say I get 3x squared plus 7 equals 4. 3x squared plus 7 equals 4. Let's start with that one. Pretty simple, pretty easy. It starts to solve exactly the way I would want it to. 3x squared equals negative 3. Divide by 3, divide by 3. X squared equals negative 1. Boom. What's the problem? I can't square root a negative. This cannot be square rooted. And because it can't be square rooted, there's no answer. And you're like, how do you not get an answer? Really easy. This parabolic curve either is above the line and opens up, or it's below the line and opens down. It has no solutions because it doesn't cross the x-axis. This is the beginning of an idea called a discriminant, which we're going to talk about later. But if negative, no solution. That's all you need to know. All right, the next thing we're going to talk about is completing the square. Probably going to be the most difficult thing that we do in this unit. It's not going to be super easy, but it's going to make some sense. First of all, what I'm going to do is I'm going to review some things for Chapter 9. And the things I'm going to review are called special case trinomials. Special case trinomials were the ones that look like this. Let's see, that one also looked like this one. In other words, if I got something that looked like this, x squared plus 10x plus 25. When I square rooted the 25, I got 5. When I square rooted the x squared, I got x. It was positive. And when I took these together, times 2, I got the middle coefficient. So I knew that this special case came from the same thing multiplied twice. Those are actually pretty easy to solve. So if we can make one of our regular quadratics look like a special case trinomial, we can solve it. We can actually work it backwards. So let's take a look at an idea of what I mean by working it backwards. Well, let's say that I had this, x squared plus 14x plus on and on. If this was a perfect square trinomial, I could find this missing piece by taking this chunk, dividing by 2, and squaring the leftover. 14 divided by 2 is 7, and 7 squared is 49. So my special case trinomial out of this would be x plus 7 squared. I take the middle coefficient divided by 2 and square it. No problems. Pretty simple, pretty easy. This is a key element in completing the square. Let me throw a completing the square problem up here, and let's see what we can do with it. All right, so let's take a look at x squared minus 2x minus 15. All right, I'm going to set it equal to 0 because I'm still intending on solving this. All right, so when we look at this, I'm going to take this particular function and I'm going to complete the square. And what I mean by that is, since I can't really move this thing, I can't really do this, what I'm going to do is I'm going to move it off to the other side. So I'm going to call this x squared minus 2x equals a positive 15. And I'm going to set it way off over there to the other side. I'm just going to leave it there for a little bit. Now, if I were to take negative 2 and divide by 2, I'd get a negative 1. So I'm going to say negative 2 over 2 equals negative 1. And then I'm going to take that, I'm going to square it and put it back in for my c value. And a negative 1 squared is 1. But if I add 1 to this side, algebra says I have to add 1 to the other side. And you're like, why did I do that? You already know why I'm doing that. Because when I factor this, now I can solve it. And I can solve it really, really, really easily. When I square root this, I get x minus 1 equals plus or minus 4. Then it becomes 2 problems. And I solve each one. And my solutions are 5 and negative 3. And now I know where my x-intercepts are. I can graph my intercepts from there. That's called completing the square. What are the processes? This one's a little bit more complex, but we're going to go over them again, just to make sure that we've got this. Step 1. Move that c coefficient to the other side. All right, once you've got that, go back to your b coefficient. Take b, divide by 2, and square it. That becomes the new c. But you also must remember to add that new c to the other side. Okay? Step 3. Factor the special case. And then finally, step 4. Solve for both positive, negative solutions. Okay, so let's draw some arrows here. Step 1, move C to the other side. We did that here. Step 2, find the new C, add it to both sides. We did that there. Factor the special case. We did that there. And then step 4 is solving the rest of it. Very simple, very easy. This is probably going to take a couple times to do it. Let me see if I can't find one more problem and we'll work it together. Ish. I know it's not really together, it's just really me working it. Now, this one, completing the square, does some neat things as well. But primarily what it is used for is finding solutions when we can do those square roots and get those irrational decimal answers. And you will get those from time to time. In this next particular case, what I'm looking to do is to solve one that's just using standard rational answers. Okay, so let's take a look at x squared minus 14x. 14x equals 51. Now, in this particular problem, they already have 51 moved to the other side. Perfectly fine. It just allows us to skip step number 1. It's already done for us. So, next thing I'm going to do is I'm going to space it out a little bit, and then I'm going to say, what is my new C value if my B is negative 14? So, I take negative 14, I divide by 2, and I square. Negative 14 divided by 2 is 7. Negative 7 and negative 7 squared is 49. So that's my new B value, or new C value. So I'm going to add this 49 to both sides of the equation. Next step, factor this. Well, I already know what it's going to be factored. X minus 7 squared. And that's going to equal 51 plus 49 is 100. As I square root this, I get x minus 7 equals plus or minus 10. At that point, I solve for both positive and negative solutions. X minus 7 equals 10. X minus 7 equals negative 10. X equals 17. X equals negative 3. And I have my 2 solutions. Pretty simple, pretty easy. There's one more trick. One more thing I want to show you about completing the square. This is why I like completing the square above all else. It really, really is fun. It's super sneaky. It's a nice little trick. It's actually not sneaky. You need to know this. It's called the vertex form of a line. And what we're going to do is we're going to go from this point, and we're going to go sideways with it. When I have x minus 7 squared equals 100. This is in the form x minus h, or pretty close to it. So I'm going to put the 100 back on the other side. X minus 7 squared minus 100 equals 0. And now that it's in this form, opposite h, plus 7, negative 100. All you do is take these down. This one changes. Change. And 7, negative 100 is my vertex. Now I can graph. And that's why I love completing the square. I have my 2 pieces, 17 and negative 3. Those are my x-intercepts. And now I have my vertex. I have my 3 points I need to graph this parabolic curve, and I'm done. And that's all there is about this. Pretty simple, pretty easy. Now, I'm going to almost call this done for chapter 10. I know this is fast. The last thing we're going to go over is going to be the quadratic formula. The quadratic formula makes everything that you've learned up to this particular point obsolete. But you're still going to have to be able to do all the pieces to pass the test. Now, perhaps you have noticed, but I have left ax squared plus bx plus c on the board the entire time because we keep coming back to those letters. That a, that b, that c value are very important. Now we're going to look at it in terms of opposite b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula, and you know this. We're going to also set this equal to 0 because it's going to tell us our x-intercepts. This one is particularly easy. Let me pick one that we have already done just for the fun of it. Oh, let's go back to x squared minus 2x minus 15. X squared minus 2x minus 15 equals 0. All right, we did this one earlier, and we found our solutions to be, as I go back and look at the crazy awesome book of knowledge. Where did that go? Okay, and our solutions were -3 and 5. So we're just going to hold that idea kind of in our head for a moment. And what we're going to do is we're going to take these values. My a value is right here, which is 1. My b value is -2, and my c value is -15. So we include those negatives in front. And we're going to go ahead and put it in this form. I need the opposite of b. b is -2, so I'm going to put -2. I'm going to plus or minus the square root of -2 squared minus 4 times the a number times the c number. And I'm going to take that all pi 2 times the a number, which is 1. It seems like a lot, but it's not. It's plug and play. It's like hooking up the stereo. You're just plugging in the chords where they belong. No problem. So opposite 2 is going to be 2. Plus or minus the square root of -2 squared is 4. Minus, we have a negative times a positive times a negative, so it's going to end up being plus. 4 times 1 times 15 is 60. All over 2 times 1 is 2. 2 plus or minus the square root of 64 over 2. Now we're ready to square root. When we square root, we're going to get a +8 and a -8. So this is going to break into 2 possible answers. 2 plus 8 over 2 and 2 minus 8 over 2. Because we have a positive square root, we have a negative square root. 2 plus 8 is 10. 10 over 2 is 5. Oh, there's our first solution. 2 minus 8 is -4. -6, excuse me, getting ahead of myself. -6 over 2 is -3. And there's our second solution. Quadratic always works. If the quadratic doesn't work, it is because there is no solution. And how do we know that? When this particular piece gives us a square root that we cannot square root. This is called the discriminant. The discriminant, b squared minus 4ac, just that part of the equation, has 3 possible outcomes. The answer might be positive, the answer might be 0, and the answer might be negative. If the answer is positive, there are 2 solutions. If the answer is 0, there is 1 solution. And if the answer is negative, there are no solutions. So you can use this thing that we call the discriminant. There we go. I learned how to spell and write and things. There we go. The discriminant. If you use the discriminant, you can save yourself some work, because if you solve this middle piece first, it will tell you whether you need to go forward. If you're sitting there going, okay, I got the positive and I got the negative, tell me about 0. How could we have one solution to a parabolic curve? And one solution to a parabolic curve can look like this. It comes down, touches right at the x-axis, and the vertex is there. Or comes up from the bottom and touches in one place. So 0 solutions means there is, or 0 as a discriminant means there is one solution. That vertex lies on the x-axis, and we're good to go. Ladies and gentlemen, this has been a busy, busy, busy morning. I've gone over a lot of notes with you guys, a ton of stuff, but this is essentially chapter 10 in a nutshell. You're going to need to come back and continue looking at this information over and over and over again for it to make sense. And you're going to need to start communicating with me. You need to send me pictures, texts, emails of the problems that you're having as we move forward so that I can help you work those. We're working on video conferencing things and some stuff like that so that we can set up, I'm going to try and set up some sort of whiteboard situation in my home so I'm not sneaking into the building. That is frowned upon. I get yelled at and things. Plus, I think we're going to move it a definite stay at home, and I'm not considered an essential worker, so for me to get in my car and drive over here would actually be against the law. So we need to follow our rules, so we're going to try and make this work from home. I thank you for your time. I hope this helps. Good luck. Stay healthy.